Sixth graders, good afternoon. How is everyone doing this afternoon or this evening? We are going to dive into lesson 2.6, estimating quotients. This is Mrs. Dubé, if you haven't guessed yet, coming to you live from room 21. So let's get to the essential question, which of course will be part of what you will be answering in your summary. How can you use compatible numbers to estimate quotients of fractions and mixed numbers? Compatible numbers. Compatible numbers to estimate quotients, fractions, mixed numbers. Wow, this is a vocabulary packed chapter. Compatible numbers are numbers that are divisible by each other, which means they have no remainder. Estimate. Use some rounding rules or don't. When you're using compatible numbers, it's whatever makes the most sense in your own noggin. Quotients, answers to division problems. Fractions, a numerator and a denominator, or another way to write a division problem. And mixed numbers, when you have a whole number and right next to it there's a fraction. You should pause the video right now if you don't understand any of those words highlighted in yellow, and you should take a second to absorb. All right, let's look at connect. You have used compatible numbers to estimate quotients of whole numbers and decimals. You can also use compatible numbers to estimate quotients of fractions and mixed numbers. All righty, unlock the problem. Humpback whales have songs that they repeat continuously over periods of several hours. Eric is using an underwater microphone to record a 3 5/6 minute humpback song. He has 15 3/4 minutes of battery power left. About how many times will he be able to record the song? So if you come over here to the right, it says, which operation should you use to solve the problem and why? Well, obviously we have to divide because we're trying to find the number of groups of 3 5/6 that go into 15 3/4. Okay, so obviously we're going to be dividing. It's kind of like he had, let's see, he wanted to record a 5-minute humpback whale song, and he has about 15 minutes. So it wants to know how many times will he be able to record that song, which is the question that they're asking us. Okay, so take away, we'll use our compatible numbers in a minute, but if you take the fractions off, right, you'd end up with 3 and 15. Okay, so obviously that would be division. All right, so one way, estimate 15 3/4 divided by 3 5/6 using compatible numbers. Love compatible numbers. Okay, because it's whatever makes sense in your own head. You know your rounding rules, but sometimes those don't apply when you're doing compatible numbers. What whole numbers close to 15 3/4 and 3 5/6 are easy to divide mentally? Because if I was to really round 15 3/4, I'd round it to 16, right? And if I were to round 3 5/6, that's really close to 3 6/6, which is 4. So I could do 16 and 4 and divide, right? Or I could do 15 and 3 too. I could just take the fractions off and do 15 divided by 3. But 15 3/4 is a little bit closer to 16, and 3 5/6 is a little bit closer to 4. And so if you divided those out, you'd get 4. Okay, so this is the word that means we've just estimated using compatible numbers. Eric will be able to record the complete whale song about 4 times. Doesn't say exactly, it says about. Moving on to the next page. In the example, it says estimate using compatible numbers. Well, let's look at it. Rewrite the problem using compatible numbers. So they kind of set this up for you right here. 5 2/3, it's probably close, we would say, to 6, right? And 5/8, well, that's really close to 4/8, which equals 1/2. So I would say 5/8 is really close to 1/2. Now, if we look at this for a second, I want to know how many 1/2s fit in 6. Okay, so say I have 6 boxes. I want to know how many halves there are. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 6 divided by a half would be 12. So when we actually divide in tomorrow's lesson, 5 2/3 divided by 5/8, our answer should be around 12. Okay, so when you're dividing by fractions, it's weird because you're ending up with higher numbers, right? Usually when you divide, you're lessening your numbers. But when I want to know how many halves are in 6, it multiplies by 2 almost, right? And you'll see how to do this tomorrow. Think, how many halves are there in 6? Okay, so 5 2/3 is, here's that word again, about 12. All right, let's look at B. 7/8, that's almost 8/8, which means it's almost 1 whole. And 1/4, I guess we can kind of just keep 1/4. That's a nice fraction. So say we have one whole object and we're dividing it into fourths. Okay, so how many pieces do we have, folks? 4 pieces. There are 4 pieces in one whole. So 7/8 divided by 1/4 is about 4. And again, the reason this number is bigger is because you're seeing how many little fractional pieces are in another amount. Okay, so you're going to have more fractional pieces, so the numbers will be bigger. So don't let that confuse you. It's a little tricky to understand. All right, if you go to the Sharon Show, we're just going to estimate using compatible numbers. I'd like you to try 1, 2, and 3 on your own, and then we will come right back and see how you did. So go ahead and pause the video, folks. Do your best. Think about it. Okay. You're brilliant. I just know it. Here's what I have. Go ahead and check your answers. Now, by the way, Mr. Damiani and I in the beginning have told you, if you already understand this, okay, if you already understand this and you don't feel like you need to watch the entire thing, that is when you may do a little fast forwarding. The problem we're seeing is there are kids who don't understand it. They're fast forwarding just to get it done, and then they're missing out on the important things and concepts that they should be watching. So if you're not getting 95 or above on everything, and you know in class maybe you're a little bit lost, you shouldn't be fast forwarding any of these videos. Okay, so but we're trusting that you have the judgment to know. If something's really easy for you and you're getting it, you can fast forward a little bit. Okay, but if you're struggling at all, it's really imperative or important to watch the entire thing. Okay, we're only at 8 minutes, so it's not like this is killing you. So let's look at number 1. I see that this would only round to 23, right? Because 4/5 is close to 5/5, which is 1 whole. But I see the 6 over here. So instead of 23, I'm going to use my compatible number of 24 with the 6 and get a 4. This one's pretty straightforward. We already have the 12. This rounds to 4, so divide, you get 3. This one would round to 34, but because I see a 5 here, I'm going to use my professional judgment, as you should too, your 6th grade professional judgment, and round that to 35, divide it by 5, and you get 7. All right, so you definitely want to use your common sense with these. Come down to the on your own. I'd like you to just do 7 and 8, and then we'll be done. So please pause the video and do 7 and 8, and we'll come right back. All righty then. Let's look at number 7. Oops, and I'm on the wrong page. So we have 44 1/4 divided by 11 7/9. I love double numbers because I know 11 goes into 44 4 times, so I haven't even looked at these fractions. I only looked at the whole numbers. 44 divided by 11 is 4, and I'm done. Love that. All right, look at number 8. 71 and 11/12 would round to 72. And then 8 3/4, well, it's close to 8, but it's closer to 9. either one would work, right? Because 72 divided by 9 is 8, right? So you could have an 8, or if you did, let's look, 72 divided by 8, you'd get a 9. So either one would work. All right, folks, I hope you got that. If not, it was only 10 minutes and 20 seconds, 21, 22. Rewatch it if you need to. This is your own learning. You need to take some responsibility for your learning. So rewind it if you need to. If you're good to go, then great. We'll see you tomorrow. All right. Have a great night, everybody, and we'll see you on the flip side.